Assalamualaikum and hi. I am Mohd Fikri Hafizuddin Azman, semester 7 student of School of Mechanical Engineering UiTM Shah Alam. Welcome to my final year project proposal presentation. My final year project is analysis of the performance of fishtail terminal of W-beam Guardrail. My final year project is supervised by Professor Madya Dr. Muhammad Azman bin Yahaya. Project summary. This study is focusing on the behavior of the fishtail terminal of W-beam guardrail during the initial phase of the head-on impact. So in order to understand the fishtail terminal behavior during the impact, a finite element analysis is conducted by using SolidWorks software. Introduction. W-beam guardrail is a safety structure that installed alongside the shoulder of the road. W-beam guardrail is ranked third in most common roadside obstacle hit by vehicle after trees and embankment. Poor design or untreated terminal end of W-beam guardrail can cause high severity accidents such as vehicle penetration if a head-on impact occurred. So let's jump into my literature review of final year project. First of all, what is W-beam guardrail? W-beam guardrail is a semi-rigid steel structure that installed alongside the road on a specific places in order to increase the safety of the road. It is installed on an area where there is roadside obstacle that considered as hazard such as tree, steep embankment and utility poles. The function of the W-beam guardrail is first to prevent the errant vehicle to crash on the roadside hazard such as tree, steep embankment and utility poles. Second is to redirect the errant vehicle back into the traffic direction. Second, the W-beam guardrail elements. W-beam guardrail is consists of three elements. The first one is W-shaped rail. It is named after the cross-section of the longitudinal rail is in W shape and each of the rail is connected by bolt. Second is the post. Post is the vertical structure that holds the W-shaped rail. And last one, the end terminal. The end terminal is the starting point of the guardrail and also known as the nose of the guardrail. The last point of my literature review is the end terminal characteristic. There is three types of terminal of W-beam guardrail. The first one is the flare end. Flare end refers to the end of a guardrail that bend or flare away from the road at certain degrees such as 15 degree. Second is the ramp terminal. Ramp terminal also known as turn down terminal. The end of the guardrail is twisted and buried into the soil. The last one is the straight extension. Straight extension is the additional length of the W-beam guardrail itself by adding end treatment such as fishtail and buffer end. Let's look at the problem statement of my final year project. So despite of the functionality and the benefits of the W-beam guardrail, the guardrail itself is also considered as hazard. A study conducted by Muhammad Huzaifah in 2010 reported that 69% of 4,424 side crash barrier was untreated. In addition, the hazardous rate in terms of poor guardrail end treatment at major expressway is the highest at 72.5%, followed by rural at 44.2% and last one the urban at 48.4%. The author also mentioned a road user who drive in major expressway is exposed at least 158 hazardous point in every 100 km travel. So the problem statement of my final year project is poor or untreated guardrail terminal, which is in this case the straight extension, can be act like a spearhead where a true head-on crash can cause vehicle penetration. Thus, cause a high severity injuries or even worse, fatal. Therefore, the objective of my final year project is to evaluate the behavior of the fiscal terminal of double beam guardrail during the initial phase of head-on impact. After that, scope and limitation. The scope of my study is to only focus on the fiscal terminal of double beam guardrail. The finite element analysis is done by using SolidWorks software. Only three mechanical properties that I observe, which are stress, deformation, and strain. So the limitation of my study is the actual performance of the behavior of fiscal terminal of double beam guardrail in real life may differ from the finite element result to many factors such as vehicle type that affected on the mass, angle of impact, impact of speed, and also the site condition. Next is the methodology. In order to design the fiscal terminal in the SolidWorks, I need to collect some data. The data here is the design specification of the fiscal terminal. I obtained the design specification from Malaysia Guardrail Manufacturer Catalog. The company is the Pristar Engineering Sdn Bhd. The second thing is the material of the fiscal. So, from my research, the material of the fiscal terminal is galvanized steel, and the properties of galvanized steel are stated as below. So, after I've obtained all the data that I needed, I started to design the fiscal terminal in SolidWorks. As you can see, there is a flowchart of the finite element analysis. Starting by designing the model of the fiscal terminal, followed by definition of material, then create a new study which is the drop test, and then the definition of mass, size, speed, direction, and rigid plane. And after that, I run the analysis and I post-processing the data. I use physics concepts in order to determine the speed. So the physics concepts are Newton's second law, impulse, and linear momentum. So the relationship here is the impulse and the Newton's second law. So after I've done calculation, the force generated by the moving car is 227,796 Newton. So drop test in SolidWorks. Drop test is used to mimic a motion of free fall item onto a rigid plane. So due to the limitation of drop test analysis, the rigid plane represent the car is set to be fixed, while the fiscal terminal is set to be in motion. So it is opposite in the actual condition where supposedly the terminal is fixed and the car is the one is moving. So the terminal is set to have the same momentum of the car. So it also create the same forces. So with the mass of 10 kg, the speed of the terminal is 2,277.96 meter per second. So because of limitation of the drop test analysis, the maximum speed needed to be reduced to 300 meter per second. So the last one is the preliminary result. So as you can see, this is the result that I obtained from the drop test analysis. So there are three mechanical properties that I observe, which is the first is the stress. The stress in the model is 65,270 megapascal, while the maximum displacement of the model is 177.9 millimeter, and the strain is 0.2583. So as you can see in the video, there is the drop test analysis where the terminal is moving, hitting the rigid plane. Lastly, thank you very much for spending your time listening to my final year project proposal presentation. So if you have any inquiries regarding my final year project, you can contact me through my phone number, and also you can email me through the email link I stated there. So again, thank you very much.